So for this second question, question number 2, to solve this, you start by writing the chemical equation. So how many liters of hydrogen will be required, will be obtained from the reaction of hydrogen, from the reaction of 500 cm3 of 0.5 H2SO4 with excess zinc. So excess zinc is what we are reacting with now. So the reaction is going to be zinc plus H2SO4, which will give us zinc sulfate plus hydrogen gas. So this is what we are going to have. Okay, so let's continue. Now for this reaction, I haven't written the equation this way. The next thing you are going to do is to get the formula. The formula is a bit different from this first one, which is molar mass of A times number of moles, and this, so it's a little bit different. So what we have here is to say molar mass of A times number of moles over the mass of A is equal to 22.4 dm cubed of gas over volume of gas. So this is the formula I came up with that you can just quickly remember to solve this. Now, what you do here, you know A is the reactant. So the reactant and the gas that is given. So for an STP, because they said at STP, so the standard volume at STP is given as 22.4 dm cube of that gas. So it's fixed. Now the volume of gas, you now have to consider it. So what is now? Let's answer for the parameters. What is the molar mass of A? So A is the hydrogen now that is required. So okay. So let's continue. Please, sorry for that break. Now we have the molar mass of A and number of moles. Then mass of A, and which is equal to 22.4 dm cube of gas and volume of gas. So that is how this is the way we solve this now. So then let's now quickly look at the molar mass of A. A is the H2SO4. So H2SO4, let's look for the mass. Molar mass of A, which is H2SO4 now. Let's better write the H2SO4 directly. Is equal to, we have 1 times 2 plus sulfur is 32 plus oxygen is 16, and we have 4 atoms of. Okay, so the molar mass of H2SO4 is 98 gram per mole. So because it's 98 gram per mole, so let's bring it into this now. Okay, first off again, let's look at the mass of A. How do we get the mass? So they told us 500 cm3 and 0.5 molar concentration. So we calculate the mass in this one. They didn't give us the mass already, so they want us to get it. So it's given as concentration times molar mass times the volume that is given. So this is how we get the mass of the substance. So to get it now, the concentration has given to us as 0.5 mole. So 0.5 mole times the molar mass is 98, which we got here, 98 gram per mole. So the volume times volume, but the volume has given to us in cm cube. So we have to convert it to dm cube. To convert it to dm cube is equals 500 cm cube over 1000. So this is how we convert it. Now this now becomes 0.5 mole times 98 gram per mole times 0.5. So this, we multiply everything together. If we multiply everything together, that will give us 24.5 grams. Now that is 24.5 grams. So we can now bring everything down to this place now. So we want to know how many liters of hydrogen. So that is the volume of hydrogen. That is what we are looking for. So let's bring it down here. We now bring it here and say mass of the molar mass of the. So we have it this way: 98 times 1 over 24.5 is equal to 22.4 and 24.4 dm cube. And volume of hydrogen is what we don't do. So we make the volume of hydrogen the subject formula. So we write volume of hydrogen gas is equal to, we make the subject formula, this becomes 24.5 gram times 22.4 dm cube over 98 gram. So that will give us, if we use a calculator, that will give us, so if we compose this 24.5 gram times 22.4 dm cube over 98, this will give us 5.6, and our answer will be in dm cube. So this is the volume of hydrogen that is required. So we can provide it to liter because it's how many liters of hydrogen we can provide. So dm cube and liter are the same thing. So we can now change it. We can now say which is equivalent to 5.6 liters because they told us to give it in liters. So dm cube and liters are the same thing. So we convert it to 5.6 liters. So this is how we solve this. So we are going to solve one or two more in subsequent videos, so we get a good understanding of the various forms of stoichiometry calculations we have in chemistry. So please like, subscribe, and share this video. Thanks for subscribing. Thanks for watching.